Hi guys, today we're working on an F equals MA exam question. And this is question 23 from the 2024 F equals MA exam. And this question is actually really interesting because we are trying to find the bounce height of a ping pong ball when it hits the paddle, while at the same time the paddle itself is moving up and down. So let's get started by reading the question first. Collisions between ping pong balls and paddles are not perfectly elastic. Suppose that if a player holds a paddle still and drops a ball on top of it from any height h, it will bounce back up to the height h/2. To keep the ball bouncing steadily, the player moves the paddle up and down so that it is moving upward with a speed 1.0 meter per second whenever the ball hits it. What is the height to which the ball is bouncing? So let's solve for the coefficient of restitution first. When a ball is dropped from height h, its speed before the collision is simply radical 2gh. After the collision, the ball rises to the height of h/2, so the speed becomes radical 2gh/2. 2 and 2 can be cancelled out, which leaves us with radical gh. And since we know that the formula for the coefficient of restitution is E equals velocity after over velocity before, so we can substitute radical gh over radical 2gh. And radical gh can be cancelled out, which leaves us with 1 over radical 2. And this value will be used for the rest of the problem. So let's look back to the question now. The problem states that the ball is bouncing steadily. This means the motion repeats itself every cycle, and as a result, the ball must leave the paddle with the same speed magnitude that it has when it returns to the paddle on the next bounce. So let that speed magnitude be v. So before the collision, the relative speed of approach RSA equals the velocity of the ball plus the velocity of the paddle. And since we know that the paddle speed is 1.0 meter per second, we can just simply plug it in. We got v plus 1. After the collision, the relative speed separation equals velocity of the ball minus velocity paddle equals v minus 1. And now we can use the definition of coefficient of restitution, that E equals the relative speed of separation over relative speed of approach. And since we already found the coefficient of restitution, we can just substitute 1 over radical 2 equals v minus 1 over v plus 1. And we cross multiply. Radical 2v minus radical 2 equals v plus 1. Radical 2 minus 1, v equals 1 plus radical 2. V equals 1 radical 2, 1 plus radical 2 over radical 2 minus 1. And we just put it into the calculator, which gives us v equals roughly 5.83 meter per second. Now we finally have the velocity. Now we can solve for the height. Once the ball leaves the paddle, it rises under gravity until the speed becomes 0. So we can use v squared equals 2gh and rearrange it, plug it in, which gives us the height. It's equal to 1.73 meter. And we can look back to the answer choices. The correct answer is D, 1.7 meters. And that's all for this problem. Thanks for watching.